Hello class, welcome to Unit 2, Video 2. Today we're going to look at slope and writing linear equations. Your learning targets for today are that you can find the slope, which is the rate of change of linear equations. You can also write the linear equation of a line. So let's go ahead and look at an example. The grade of a road is a percent that measures the steepness of the road. It is found by dividing the amount of road rises by the corresponding horizontal distance. Okay, so the way you calculate grade is you take the rise over the horizontal distance. So this is an example of slope. Remember, slope is rise over run. Okay, so here's my rise and the horizontal distance is my run. So when they calculate grade, they are calculating slope. Slope. The slope of the line is the ratio of the change in y coordinates to the change in the x coordinates. Okay, if I come back here to this picture, if you think about your xy axis, if I just go ahead and draw one on here so it's not very straight. This is my x-axis. This is my y-axis. So your rise is your change in your y's over your run, which is your change in your x, because this is my x-axis. So slope can be found by the change in the y's over the change in the x. So the way we calculate slope is change in y over change in x. Mathematically, the way that we write this is the slope formula. You're going to want to remember this. It's y2 minus y1 over x2 minus x1. Okay. Some equations of lines are if we have a positive slope. So if I calculate this and I get a positive number, your line rises from left to right. Biggest thing when you read a graph, you always read it from left to right. Okay, and as I look from left to right, it's going upward, so it's a positive slope. Okay, the next one has a slope of 0. Whenever your slope of 0, whenever you have a slope of 0, your equation is y equals whatever the y value is. In this case, if you see, it's 2, so y equals 2. Some people will look at this and like, I don't remember what the equation would be. Remember, your ordered pairs are x, y. And so my point here, my y's, if you notice, they're both 2. That's how I know it's a y equals 2 equation. Okay. The next one has a negative slope. The reason I know it's negative is because if I look from left to right, it is going down. Okay. And the last one, anything that is up and down is an undefined slope. The way that happens is when we have some number in the numerator divided by 0. If you type that in on your calculator, you'll get an error because you cannot divide by 0. So that would be an undefined slope. So this is what causes an undefined slope. Then the equation of this one, if I notice, my x's are exactly the same. So my equation for this one is x equals negative 2. So big things to remember, horizontal lines, y equals 2. Remember, horizontal horizon. Vertical lines, remember you jump up and down vertically. Okay, that's an x equals equation, negative 2. Some other equations that come up frequently throughout Algebra 2, and you also see on the ACT, is knowing what is the slope for parallel lines and what's the slope for perpendicular lines. So lines have the same slope. What kind of lines are these? These are parallel. Okay, so if they're parallel, they have the same slope. That's what makes them never touch. So one way to write this is the slope of the first line is equal to the slope of the second line. So when the slopes are equal. Lines have slopes that are opposite reciprocals of each other when they are perpendicular. Remember, perpendicular means they meet at an at a 90-degree angle. So if I have the slope 1, the way I would get it to be opposite, if this one's positive, I make it negative, and reciprocal, so it's 1 over the other one, okay? Another way to check that you have the correct slope is if you take your slope 1 times your slope of your other line, it should equal negative 1. Okay, so that's a good way to check to make sure it's right. So example 1, it says find the slope of the line that passes through the 2 points given. Okay, so this is where we're going to go ahead and use our our slope form. So my slope is equal to y2 minus y1 over x2 minus x1. I want to point out, doesn't matter which y value you go with first, as long as you stay consistent. So if I pick this y value, I subtract this one, and I do the same order for my x's. Okay, this would work out. If I choose to pick this one as my y2, I would have to subtract this way. Then I would start with this and subtract. So for instance, let's just do both of them really quick. This one, -2 minus 4 over 1 minus a -1. This gives me -6 over +2, which is -3. Okay, so I started here and went to this way. Now what if I do it the opposite direction? Okay, now I'm going to go from here to here. So what if I have 4 minus a -2 over, go backwards, got to stay in the same order, -1 minus 1. That gives me 6 over -2, which is also -3. So it doesn't matter which one you start with first as long as you're consistent. Okay. B. So my answer for A is -3. B, I would like for you to try this one on your own. So please pause the video and try B on your own. Hopefully you had a chance to pause the video. So for this one, I'm going to do 2 minus 2 over 3 minus a -3. I have 0 over 6. 0 divided by 6, if you're not sure if that works, try it on your calculator. It does work, so this is an m equals 0, so that is my slope for this one. And remember, graphically, if you don't remember what the equation would be, notice that my y's are the same, so it's a y equals 2 equation. That'd be the equation of the line. All right, example 2. Graph the line with the given conditions. All right, so we're just going to show you all this. So for A, it says a slope of 1/2 and it passes through 2, -1. So my recommendation is start with the point first. Let's plot 2, -1. 2, -1 here. And then my slope, it's rise over run. So I'm going up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2. Or down 1 to the left 2. Down 1 to the left 2. Okay. And do your best. You guys can take out I would use a straight edge of some form to sketch these on there to make sure they're nice and straight. All right, B passes through -3, -4. So 1, 2, 3, 1, 2, 3, 4. So there's -3, -4. My slope's -3. So it's really -3 over 1. So this means that I'm going down 3, right 1. Okay, so down 3, right 1. What if I want to go the opposite way? It would really be up 3, left 1. 1, 2, 3, left 1. There would be my equation, or sorry, here would be my line graph for this one. Excuse me. Another way to check to make sure you did it right is, sorry, I'm like struggling to graph this. There we go. It's a negative slope, so if I look from left to right, is it going downward? Yes. This is a positive slope. As I look from left to right, is it going upwards? Yes. Okay. The next thing we're going to talk about is rate of change. This is something that comes up frequently. Rate of change is the same as slope. Okay. You're going to hear this a lot, so you got to get it in your head. Slope. Okay. So measures how much a quantity changes on average relative to any other quantity, often time. Just so you know, when we do talk about time, time is typically your x value. Okay. So if I have the ordered pair x, y, it's typically that my x is time and my y is a value, whatever value. So for instance, if I look at what I have here, x would be my days. Days can be their form of time, and y would be my height, okay, which is the other value. So 3, Lynn is tracking the progress of her plant's growth since she bought it. The growth is modeled in the table. It says, what is the average rate of change? So get used to seeing this, average rate of change for the plant's growth per day. Average rate of change means to find the slope. There's a few ways that you can do this. You can pick 2 points and find the slope. So if I wanted, I could just pick, I'm going to pick this one and this one, just any 2. So I would have 4 minus 2 over 9 minus 6. This gives me 2 over 3. So my slope is, oh, I messed that up, didn't I? Let's backtrack there. What did I do wrong? Because this is a common mistake. So let's learn from my silly mistake that I just did here. A lot of people will put the x's on top, and I did that because it was in the table. So I made a mistake. I need to switch these 2 around. Okay, so remember, y's on top. So let's go ahead and change it. And let's hope that you don't do that, learning from my mistake. So I would have 9 minus 6 over 4 minus 2. There we go. So I have 9 over 6, which is 3 over 2, which is the same as 1.5. So that means the plant's growing at 1.5 centimeters per day. Okay, that's one way to see it. Okay, the next way to see it is look at how it's changing in the graph. So if this is counting by ones, okay, has to be counting by ones, your slope can actually be found by just looking for the change here. Okay, so it has to be ones up top. So how do I go from 6 to 7.5? I would add 1.5. 7.5 to 9, add 1.5. Okay, so that's where I would also get my 1.5 centimeters per day. It says, what is the starting height for the plant? Well, we want to figure out what it is at day 0. So we could do two things. We could work our way back, okay, to 0. So if I were to add on to my chart, what would I have? Don't have a lot of room here, but if I were to add at day 1, okay, what is 6 minus 1.5? That's 4.5. Day 0. How do I go backwards? I would subtract another 1.5, which would give me 3. So that means on day 0, the starting height was 3 centimeters. Okay. Another way you can use it is by using your equation of a line. Remember, the equation of a line is y equals mx plus b. I know right now that my slope is 1.5 from the problem above. Then in order to figure out what I'm starting at, that's your b value. So I can pick any one of these points, plug it in, and solve for b. So I'm just going to pick the first one, 2, 6. My x is 2, my y is 6. So I would have 6 is equal to 1.5 times 2 plus b. 1.5 times 2 is 3 plus b. And if I subtract, I get 3 is equal to b, which is also what I have here. Okay, so multiple ways to approach these. Okay, then C says write a linear model that represents the height of the plant after D days. Well, we know that it's growing at 1.5 centimeters per day, plus we put our starting point, 3. Y equals mx plus b. So there is my plant growth modeled in my equation. If you have any questions on example 3, please let me know, write them down, and come and ask. Tables like this you will commonly see on the ACT. All right, so we have a question about money. Kevin's savings account balance changed from $1,140 in January to $1,450 in April. Find the average rate of change per month. Okay, once again, average rate of change is just finding the slope. Okay, so January is the first month. So really I have this ordered pair. In my first month, it was $1,140. April is your fourth month. And so I would have another ordered pair. I'm just going to write that one a little nicer. So January is the first month, $1,140. Then my fourth month, I have $1,450. Average rate of change is to find the slope. There will be a problem like this on your quiz, so make sure you understand what average rate of change is. And so I'm just setting up slope. This minus this, 4 minus 1. If I go ahead and subtract those, I have 310 over 3. And if I divide it, this is money, so I only round to 3 decimal places. I'll get $103.33 per month. So make sure you label correctly. I will take off this time if you do not label correctly. So there it is, per month. Okay, any questions on example 4, please make sure you write them down and come and ask. Slope-Intercept Form. I've already used it a little bit earlier. Okay, but let's just go ahead and take a look at this one. So, slope-intercept form of a linear equation, remember, is y equals mx plus b. And just to remember, m is your slope. B is your y-intercept. What I like to tell people is B is where you begin. M is how you move. Okay, so that's my slope-intercept form. There's 2 equations you can use. There's point-slope form, so given a slope and point, you can use the equation y minus y sub 1 is equal to my slope times x minus x sub 1. Okay, so you can use point-slope form if you're given a point and the slope. If you're given 2 points, okay, first thing you need to do is find the slope and then plug your point or your slope and a point into point slope form. So let's just look at some of these examples. There's a few ways to approach it. One way is not more correct than the other. So example 5. It says write a linear equation in slope-intercept form that for the line that has a slope of -3, 2, and passes through -4, 1. So this is where we would recommend using point slope form. So it's y minus your y value. This is my x, this is my y. So it's y minus 1 is equal to my slope, -3/2, x minus your x value, so minus a -4. If I solve this, I'm going to distribute this, -3/2x, and then -3/2 times, this is really a +4. Just going to do a little note up here. So it's really 3/2 times 4, which is 4/1. 4 is divisible by 2, so I would be left with 2. So this gives us 6, so plus 6. And then I would add, sorry, this would be a negative, right? Negative times positive, so -6. Then I would add the 1 to the other side, so I would have y is equal to -3/2x minus 5. Okay, that's option 1, using point slope. So when they give you the point and the slope, I highly recommend you do it. If you forget point slope form, don't forget your other equation. Y equals mx plus b. What do I know? I know my slope is -3/2. I know my y is 1, and I know my x is -4. Plug them in and solve. I have 1 is equal to -3/2 times -4 plus b. Okay, so we just went over this. Negative times negative in this case will be positive. 3/2 times 4 will give us 6, just like we got before. If you don't feel comfortable, you can use your calculator. And then plus b. We're solving for b. So in order to get b by itself, I would subtract 6. So -5 is equal to b. Just don't forget to write your final answer out. Your final answer would be, including your b and your slope. So your final answer is y is equal to -3/2x minus 5. Look, you got the same answer. Either way will work. It's whichever one you feel most comfortable with. Okay. Number 6. Sorry, just going to move it to the next page. So number 6, read it and try it on your own if you can. So number 6 says, write an equation in slope-intercept form for the line that passes through those 2 points. All right, I have no slope, so I have to find it. So this one requires me to do a few more steps. So I got to find my slope, so I'm going to do 5 minus 4, my y is subtracted, and then -4 minus a -1. Okay, this gives me 1. Add this, -4 plus 1 is -3, so my slope is -1/3. Okay, then no matter which route you go, just pick one point. Doesn't matter which one. I'm going to pick the first one. Here's your choice, point slope or slope intercept. Okay, I'll run through them both one more time and then you can choose which way you want to do it. So point slope, it's always y minus your y value, which is 4, is equal to your slope. Then x minus your x value. So it's really minus -1. I distribute my -1/3. So I have -1/3 x. This is really plus 1. So I would have -1/3. Then I would add 4 to both sides. All right, so y is equal to -1/3 x. And then 4 minus 1/3. You can write it a few different ways. You could write it as 3 2/3, or I would recommend getting a common denominator. So if I have -1/3 plus 4, it's really 4/1. I would say this is 12/3. -1 plus 12 is 11. So I would have plus 11/3, which is the same as 3 2/3. Okay, so there's using my point slope form. The other way is to use y equals mx plus b. My m is -1/3. My x is -1. My y is 4. Plug them in. I have 4 is equal to, it's -1/3 times -1, so I'm going to have 1/3 plus b. Same case. I would subtract 1/3, which gets me back to this problem, so I would have b is equal to 11/3. Just remember to write your final answer with your slope and your y-intercept. X plus 11/3. Okay, either way you want to do it, that is your choice. Okay, let's go ahead and do number 7. Number 7 says write an equation in slope-intercept form for the line that is parallel to y equals 3x plus 1 and passes through 2, 3. We want to be parallel. So remember, parallel is the same slope. So I would say to myself, well, what is the slope of this line? It's whatever's in front of my x, so my slope is 3, and I have my point 2, 3. I'm going to do this one in point slope. If you want to use y equals mx plus b, go ahead and then just check your answer with mine. So point slope, y minus your y value, 3, is equal to your slope, 3 times x minus your x value, 2. I distribute the 3, so I have 3x minus 6. I add 3 to the other side, and so I get -3. So y equals 3x minus 3. That is your final answer for 7. All right, we have one last question on this set of notes. Number 8, a salesperson, Eric, is paid a daily salary plus commission. When his sales are $1,000, he makes $100. When his sales are $1,400, he makes $120. Write a linear equation to model this situation. Okay, so his sales decide what his commission is. So I really have 2 ordered pairs. $1,000 gives him a commission of $100. Okay, and when his sales are $1,400, his commission is $120. So what I need to do is figure out, well, what is his rate of commission? So we're going to find the slope. So my slope is equal to my y, so 120 minus 100 over 1,400 minus 1,000. This gives me 20 over 400. Okay, the zeros cancel, so I have 2 over 40, which reduces to 1 over 20. Okay, so I want to have a linear equation. So this is my slope. I'm going to pick a point. I'm going to pick the top one. Doesn't matter which one. And then put it into point slope form. So we have y minus our y value, 100, is equal to my slope. And then I have x minus 1,000. So I have y minus 100 is equal to 1 over 20x minus 1,000 times 1 over 20. It's really just 1,000 divided by 20. You can do it on your calculator. Gives you 50. If I add 100 to the other side, negative 50 plus 100 is 50. So here's my equation that models his commission. Okay, his daily salary plus commission. So what this means is that his daily salary is $50 plus he gets paid 1/20th of his commission. Another way to think about it is, okay, for every $20 that he makes in sales, okay, so every $20 in sales, Eric gets $1 in commission. Okay, so that's one way to think about it. Okay, any questions on Unit 2, Video 2, please let me know. Otherwise, you can go ahead and work on Unit 2, Practice 2, and have a great day.